Welcome you all my lecture series of Principles of Compiler Design. In this video, we are going to see the topic on loop optimization. So what is an optimization means? In the optimization, we are applying some of the techniques in our program to improve the performance and efficiency and running time and space of the given programs. So in the optimization, we have the two types that can be applied in the different ways. One is the flow of control optimization and functional or flow of control, and next one is the loop optimization. So the loop optimization main objective is we have to decreasing the number of times the loop is executed in the particular looping. So the most execution of the time of our program is spent on the inner loop. So we can reduce the or decreasing the number of statements in the inner loop. We can improve the performance of the particular looping or particular program. So what is the main objective is we have to identify the bottlenecks and pinpointing that where the performance is lagging in the particular statement. So after identifying the bottleneck, we are going to select the correct optimization techniques and apply the particular optimization techniques in the particular looping, and that will reduce the execution time and improves the performance of the program. So in the loop optimization, we have the set of techniques is there. So the techniques are code motion, loop unrolling, and loop jamming, and induction variable elimination. So we will see the all the code techniques one by one with an example. So what is the code motion means? In the code motion, we moves the set of code outside the loop to improve the performance of the particular program. For example, consider you have a for loop. That for loop, it contains the two statement. So inside the for loop, we have the two statements. So in the code motion, once we find out the code to move the outside means which code is not computed in the particular inner loop. So in the two statements, the main objective of the for loop is we are incrementing the x value by multiplying the every iterations. So there is no need of the particular statement of x is equal to a plus b is not calculated in the all the times. So that loop invariant code is identified. Here the a and b are the loop invariant. So that statement is moved outside the loop. So the optimized code, the x is equal to a plus b is outside the loop. The loop one contains only the c of I x star of I. So in the code motion, the loop invariant is identified. That loop invariant is moved outside the loop and the performance is improvised. Next is a loop unrolling. So what is the loop unrolling means? We can duplicate the body of the loop multiple times in order to decrease the number of times the loop condition is tested. So we can duplicate the loop in the multiplied times in the particular loop. It is a loop unrolling. So instead of decreasing the test conditions, we are duplicate the number of body of the loop in the multiple times. For example, we have the code like in the for loop, the hello word is printed 5 times. So instead of using the for loop, we can unroll the for loop in the program by typing the statement by using the statement print statement 5 times instead of using the for loop. So in the optimized code, we are unroll the for loop and print the hello statements 5 times using the printf statements. So that is the loop unrolling. Next is a loop jamming. So what is a loop jamming means? We are combining the two or more loops in a single loop. So it reduces the time taken to compile the many number of loops. So instead of having the many number of loops for the same set of testing conditions, we are combining that many number of loops into the single loop. That is a loop jamming. So the example for the loop jamming is we have we have the code like in that left hand side we are using the two for loops. In the two for loops the testing condition is same. So we are combining that two for loop in a single for loop in the optimized code. Here the two for loop is combined and two different statements in the particular two for loops is combined into the single for loop in it's combined in the single loop. That is a that produces an optimized code. So that is the loop jamming. Next is the induction variable elimination. So in that the induction variable is identified. We are remove the induction variable from the outside the loop to improve the execution speed. So for an example, we have that the left hand side we have the particular unoptimized code. Here the in the for loop we are in the for loop is main objective of the for loop is the for loop is executed 100 times, but every time the value of j is incremented by 4. So that is the main objective. So here first step is we have to identify the induction variable. Here the induction variable is j. So and also next we have to use the cheaper statement instead of the costlier one. So in that multiplication is reduced into that cheaper one of additions. So the right hand side we have an optimized code. In the optimized code, here the j is moved. That j is an induction variable. That j is moved outside the loop, and initializing is done in the particular outside loop. So after that, and also second thing, we are using the cheaper addition inside the loop. That could be improvise the performance and also reduces the cost of the executions also. So in the induction variable elimination, the main thing of compiler is they have to identify the which one is the induction variable. That induction variable is moves outside, and also identify the costlier and cheaper statement. So we are using the cheaper code instead of the costlier code. So this is the four set of loop optimization techniques. Now the simple case study means we are applying this target to the two group in the company. One is the designer group, developer group, other one is a compiler engineer group for optimizing the video loops. So in that optimizing, in that scenario, in that case study, they are dividing into the two groups. We have the developer group is right that unoptimized loop for the particular video app conditions, and the compiler engineer loop is apply the loop optimization in the particular loop. So the loop optimization is using the in the refactoring loop is using that particular loop optimization techniques, and finally two set of loop is tested and based upon the execution and performance, and find out that the loop optimization technique applied code is performs well compared with the unoptimized loop. So this is the case study. This is a case study is given into the particular company group, and find out that performance of and importance of the loop optimization. So I hope that you will understand the what is the loop optimization, and where we have to apply the loop optimization, and what are all the techniques in the loop optimization. Thank you.